G'day, it's Robbie again. Recently I saw an interesting video where a guy who was doing metal brazing with an oxyacetylene set, instead of using conventional rods, hard bronze rods and soft rod for plumbing, instead of using either of those two types of rods that most people would use, he used plain old copper wire, just the core out of electrical cables, and he brazed some steel together with it. It did a great job. I was pretty impressed. But of course he had oxyacetylene and I don't have that. I have an LPG based system which is equivalent to MAP gas. So I'm going to give it a go today and just see how it goes, to see whether my little system can actually melt copper, use that instead of hard bronze rod. I mean, after all, hard bronze rod is basically 80% copper anyway. So we'll see how we go. We'll give it a crack and see how it goes for usability, strength, and how much heat you need. So all right, we'll get into it. To do this, I'll be using my LPG torch, which is a specialised torch that can handle hard bronze brazing. It's a bullfinch, and there's videos on my site, on my channel, showing you the torch in action and explaining a bit about it. But of course LPG is not a patch on oxyacetylene. It's equivalent to MAP gas really in this application. So you must insulate your work. You can't afford to have a heat sink taking away the heat from the work, so you don't braze on anything solid. You use light gauge metal as an insulator. In this case, we're using some square section, thin wall square section. Now I'll be using 2.4 mil manganese rod on one part of the experiment. Then we'll be using some copper wire, electrical copper wire, on the other part of the experiment. And basically I've got some 4.8 mil steel rod, and we'll basically bronze it in a T-section on each end, so I've got enough for both ends. This is galvanised, but I buffed it back to try and get rid of any oxidisation, but we will use flux to do this because it's not new metal. Alright, we'll get on with the job. First off, we'll use the normal general purpose rod, and you can see I've got the work pinned against the rod with a little bit of scrap steel just to stop the blast from the torch moving it around. Okay, that didn't take long. Now we'll turn the rod around and do the other end with the copper. That was interesting in that it seemed that the plain copper took more heat to melt than the manganese bronze. So it looks like I'd expect this to be a pretty strong bond. It's an interesting exercise, and as you can see, the bronze on this end is all the way around. It's capillated right through the job. It's given good coverage, complete depth, and it's done a good job. The copper looks equally as good. It's capillated all the way through, and it's given good coverage. So both of those welds, both of those filler welds, are as good as you could expect to get using a filler rod. So what I'll do now is I'll put one end in the vise, and I'll put the other end in a pair of shifters, and I'll give them a twist and I'll see which one breaks first. Should be interesting. I've clamped the copper end in the vise, trying to keep it just on the centre line so it doesn't have any effect on the weld itself. And on the top, on the bronze, I'll use a flat face shifter, and I'll put it on once again, try and keep it on the centre line, and I'll give it a twist and we'll see what happens. It'll be interesting. The rod is twisting, but the copper is still holding. Neither weld's given way. So you've got to say that copper weld is equally as strong as that bronze in this test anyway. So I suppose the next test would be now to see whether I can in fact use copper wire to braze a carbide cutter onto a piece of steel and use it. We'll try that next. Right, well, I've just done a quick and dirty grind on this just to test out the concept. I've just put a step on the end of it, bit of a point, a bit of a relief, and we just bronzed on an old carbide tip that I've got laying around, and we'll do it with copper. So, see what happens. To do this, you always key the surface that you're going to bronze onto. So basically, put a layer of bronze on here first, then put your tip on, and then bronze down through the centre along the edges and bronze it all together. So that's how I do it. I find that works pretty well generally, so we'll give it a crack. Right, well, the copper is definitely not melting as easily as the bronze with the manganese in it, so we'll have to up the ante on this, and I'll use the big torch as well. Right, well, obviously the copper is takes more heat to melt than the manganese bronze GP rod. So it looks like, while LPG can only do small diameter stuff like I showed here, where you're not losing a lot of heat, you did that quite easily. Once you get into something bigger like that, even with a second gun on it, it's not enough. It's purely the domain of oxy. So if you've got oxyacetylene, yeah, sure, I think that this would be a great substitute for GP rods. It'd save you a lot of money, and it certainly is strong enough to do the job. It's just that with an LPG torch, and a MAP torch MAP gas would be exactly the same. It's just that little bit too much heat required to melt it and get it to flow properly on bigger stuff like this. So anyway, interesting experiment. Certainly for this sort of stuff, small diameter work, I mean, it did that no problem at all. So if you were, say, making up, grill mesh or something like that, or repairing, say, carburetor linkage or something like that, something small diameter, certainly up to this size, no problem whatsoever. Once you get onto this bigger stuff, this sort of gun is just not good enough to do it, and you basically have to use oxy. Anyway, I hope you found it interesting. I found it interesting. It's something that I hadn't pre-run or done before. This is purely straight out off the press as you see it, and yeah, interesting experiment. Okay, see you next time. Cheers.